everyone. At this point in time, phones need to get put away in your pocket. They should not be out for any point in time during this hour. Also, earbuds, friendly reminder, earbuds need to be removed as well. Headphones, all that stuff, so that way you are paying attention and focusing in on what we're going to be talking about today. Yes, question?
Is that a supercharger?
No, it's an engine.
Yeah, but like,
He's asking if it has a supercharger on it.
No.
makes a little supercharger.
Anyways, what are we going to do this week? Well, I got blocked out at least today, tomorrow, and Wednesday. We're going to be covering engine fundamentals, letting you guys kind of get the base idea or fundamental idea of how an engine operates and works. Again, this is foundational information that you must understand and know before we actually start going into the specifics and more details of the different systems that are involved in engines. Okay? So, for instance, first lab's going to be oil change, right? The lubrication system. Before I can talk to you about how that operates, you need to have a base idea of how an engine operates. So then that way when we go and talk about lubrication systems, things make sense for you, okay? We are looking at probably Thursday and Friday. At least I have blocked out right now, introducing you to and teaching you how to use a torque wrench, okay? Probably the most important tool that you know how to use for the school year. So we're going to spend some time talking about what a torque wrench is, how to operate one, when you would use one, when you would not use one. And then I've got a really cool demonstration that we can do. I have a very expensive piece of snap-on equipment that I'm going to let you guys play with the torque wrenches, okay? So that's kind of what's going on. But anyways, today we're going to be taking notes. So go ahead and get out your notebook, open to a fresh sheet of paper, and then like with any time we take notes, make sure that you are writing down the topic, your name, and the date. Today is the 16th. So again, just to kind of get things situated here, we are going to, or at least I'm going to start you off and then turn it over to you. So topic's going to be engine fundamentals. Let me get it over here. Engine fundamentals. Gatsky, and it is the 16th. While you are getting out notebooks for taking notes, just a pleasant reminder that we're down to 25 days to get SP2 done. Automotive Service Safety and the Lift Institute, Lifting It Right. By the end of this week, you should have modules 2, 3, 13, 7, and 9 complete. Hopefully you've been making progress on that when we've given you opportunities in class to do that. But yeah, just a reminder on that, okay? I also want to let you know that this presentation that I'm going to be sharing with you today is being recorded, okay? Mostly the audio that I'm going to be talking into, okay? But also recording the what you see on the screen. All right, so if for whatever reason you are not here maybe tomorrow or Wednesday or maybe you're not here today, this is going to go up later on my YouTube channel, which is then going to be linked in Google Classroom. Okay, so if you're watching this at this point in time, please make sure you like and subscribe so that way I can get that ad revenue, because money, 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 y'all, to my millions of subscribers, okay? You guys ever heard of Cletus McFarland? No? Whistling Diesel? Yeah, okay, I'm better than him. I have just way more subscribers. It's kind of one of those things. Just kidding. Hopefully none of them are actually watching my stuff. But if they are, give me a shout out. There we go. All right, engine fundamentals. So next thing we're going to end up doing. Oh, is this going to work? Come on, work. Yes, excellent. Okay, here's our standards. This is stuff that you need to know. Again, ASE finds that this is important information that you need to know in this class. So from this information, I need you to derive a question or two questions that you can write up here. Okay, we're not going to answer that now, but later on when you go to summarize stuff, you might want to answer the question. So here's what you need to know. Students, you will be able to utilize safe procedures for handling of tools and equipment. This is not the right standards. No, down here, this is more important. So let me go to these two standards down here. These are more important. So A1, B1, identify cylinder head and valve train components and configurations. And then identify engine block assembly components and configurations. So those are the two standards we're going to work on. This stuff here we're going to talk about next week. Okay? So for your essential question, hone in on the bottom two. Identifying cylinder head and valve train components and configurations. Identify engine block assembly components and configurations. Okay? So I'll give you guys a moment here to kind of process that and maybe ask a question. Again, want to reiterate this because again, this is kind of a review. Each person's going to have a different question. You might not know some things about what we're going to be talking about today. This is totally fine. There might be some information you do know about today. Perfectly fine as well. Try to write a question about something you're curious about. Yes?
So do the torque wrenches that we have measure us how much leverage we have and when to...
Not so much leverage, but torque.
Oh, okay.
Yeah. The twisting force. We'll talk about that Thursday and Friday. I got some really expensive ones, and I got some not as expensive, but
Not bad.
once you know how to use a torque wrench, you can use any torque wrench. It's kind of like driving stick shift. Once you know how to drive a manual, you can drive any vehicle. It's kind of fun. All right, let me put this down here temporarily. Again, I'm going to write an essential question up on the board. Again, if you want to use my question, awesome, but please make sure that you are not erasing your question. All right, just add my question to yours. But again, my question is just as valid as yours. You do not need to write this down. So I'm going to say, okay, we're going to obviously talk about engine fundamentals, identifying cylinder head and valve train components, identify engine block assembly components. Maybe I don't know necessarily what those are. Cool. I'm more curious about, how does an engine work? Right? It's kind of a fundamental idea or concept that we're going to be talking about through today. And in that question, we're going to be talking about cylinder heads, valve trains, engine blocks, the components of an engine, and how they all work together, and what they're supposed to be doing. Because I think a lot of people just take advantage, right? They hop in the car, they turn the key, and they expect to go. What happens if that doesn't work? You might have been in a situation like that once or twice. Okay? So, in order to be able to know how to fix it, we have to know how it works. All right, moving on. This is a little slower on this today. There we go, or I have to be closer. With most of our presentations, I'm going to have kind of a diagram or a picture here, color-coded, to kind of help break things down in terms of how it's put together. All I'm going to ask out of you is to kind of give you a generic drawing on your own lab sheet, right? You don't need to have all these details, okay? As an example, right? I've got 10 different parts. What I might actually start doing on my notes is just kind of drawing blocks. You're like, okay, it's like Minecraft in here, right? There we go. And this is going to be the valve cover. Okay. Underneath the valve cover, it looks like I've got this like thin rectangle piece. That's the valve cover gasket. Oh, my L looks like a V. Valve cover gasket. Again, feel free to abbreviate. Then I got a larger block here. Oh boy, this is not very good 3D drawing. Apologizing for that now. That's going to be your cylinder head. So on and so forth, right? Maybe I'll come in here. Now I got the gasket, or excuse me, the head gasket. This one's a little different. So it's like a square, but then we kind of got this round thing. I don't know. Got some holes there as well. That's the engine block. All I'm saying is this thing does not need to be pretty. And we got some weird. Oh boy, that's ugly. Right, I'm just throwing something in here so that the order in which this is probably more important than how it looks, right? You need to know that the valve cover is on top of the cylinder head. You need to know the cylinder head is on top of the engine block. In between the cylinder head and the engine block is the head gasket. Get what I'm trying to say here? Okay, so the order is more important than what it looks like. Okay, the oil pan is all the way on the bottom. Okay, inside the engine block we have our piston. Inside our cylinder head we have our valves and our camshaft, at least in this configuration. All right. Kind of fun with that. Does anyone know why red is used on the valve cover gasket? Or excuse me, the valve cover.
Where would I put it? Camshaft, valves, piston.
The valves and the camshaft would end up going in here. Obviously, if they were in the cylinder head, you wouldn't be able to see them very well. Same thing with the piston. Now, there are some objects on here that are grayed out on purpose because that's information I'm not sharing with you right now. We will be talking about that stuff later on, but for the diagram, not on there. Hi, morning. But for the most part, this is what you're going to find on pretty much every single engine. Gas-powered, 4-stroke, okay? Please keep in mind that, again, there are various different kind of ways that we could structure these engines. They're going to come with more cylinders, okay? They could come with like different configurations. But in general, again, this is engine fundamentals. This is what every internal combustion engine is going to have for components. Okay? So that's how that goes. All right, we'll give you guys like 30 more seconds here, then we're going to move on. I don't want to spend all day just drawing pictures and stuff on this because there is information about how these components fit together. Anyways, I asked earlier, why is my valve cover red? Because it makes more horsepower. If it's red, it goes faster, right? And it's just kind of like you open up your hood, you look right at the valve cover, you know it's like chrome or red. Oh yeah, baby. That thing's at least got an extra 4 horsepower just because of the color. Okay. When we go out in the shop, you guys start working on stuff, you're going to get assigned the protege. Quite a few years back, we actually took the valve cover off of the protege, and I let some of my advanced students spray paint it red, and then we reinstalled it so it looks more crazy than it does. It doesn't actually add horsepower.
Yes, it does.
It just looks kind of like it would. Okay, moving on. Usually speaking, or typically speaking, when it comes to our presentations here, I gotta get close to this thing. My batteries must be, I don't know. We're gonna have some abbreviations, okay? These abbreviations are standard lingo that's used in the industry, okay? I wouldn't say that this is necessarily like vocabulary, but the abbreviations or acronyms are going to be used more often than actually fully explaining what it is. So TDC, top dead center. BDC, bottom dead center. We'll talk about where TDC is in our engine and where BDC is in our engine later on in the presentation, but I'm going to refer to it as TDC and BDC. All right, if you want to know what those mean, you can write that stuff down in the notes and refer back to it later on, okay? TDC is probably going to be more talked about than BDC, just for future reference. Okay, top dead center, bottom dead center. All right, here we go. Is that food? No food. Boy, I need to work on my. Here we go. All right. The combustion chamber. Vocabulary word. Combustion chamber is the area between the top of the piston and the cylinder head. Okay, so if I'm going to come in here and draw this, here's a. If I were to cut the engine open, okay, the area that's considered the combustion chamber is going to be this area right here in red. Okay, this area. So it's the top of the piston, which is right there, and essentially this domed area is the bottom area of the cylinder head. Okay, that comes to form a chamber that's sealed, and all the magic happens inside that area. Yeah.
That's where the gas explodes, correct?
Yes. Yes. So think of this kind of like our nuclear reactor. All the energy that we are going to transfer is going to be essentially put in here, and then we're going to harvest that energy in order to power the engine. Okay? But that's the combustion chamber right here. I'm going to go ahead and delete that. So again, I might just come in here and write combustion chamber. Okay? Equals, let's see here, area of piston and cylinder head, right? And if you want to, you can attempt to draw that, although that's going to be a lot of detail for you to draw. Okay, you could just come in here and say, okay, here's the piston, right? And just come in here. Right? This is that. That's not a really great drawing, but maybe that might highlight some stuff. Okay, so that's a combustion chamber. Oh, I gotta exit out. There we go. All right, going back to 2. Ooh, moving pictures. The crankshaft converts the reciprocating motion of the piston into useful rotary motion. All right, now again, I want to just kind of explain this real quick. Do you see the piston here? Its motion is going up and down, okay? Whoa, I didn't mean to touch that. There we go. Piston's traveling up and down. All right, that's what we would call lateral movement, back and forth, up and down, okay? That piston, as it's moving up and down, is connected to the crankshaft, which is actually turning into a circle. Okay, so the whole crankshaft, this thing here, is responsible for turning the up and down motion of the piston into rotary motion. Because our tires on our car doesn't go back and forth, they go in a circle. Okay, so that's the concept there. You can see kind of a breakdown if we had 4 pistons, how all those traveling up and down would end up moving everything in a circle. Rotary motion. Something that you might be able to relate to if you've ever ridden on a bike, right? I would assume a lot of people in here have been riding on a bike. What motion does your feet move in as you are pedaling the bike? Right? Your feet are traveling in a circular motion, right? On a bike. Okay, what direction are your knees moving?
Up and down.
Up and down. So, what's the engine on your bike?
Your legs.
Your legs, okay? Your legs, your knees specifically act like a piston, and your feet are connected to the crankshaft. Your body is doing the same motion that's in our engine. Okay? Just kind of to link that learning that you already know about to this. Okay, and again, you could come in here and say, crankshaft converts, okay, crankshaft oops, I'm not spelling that right. Crankshaft goes up and down to circular. Just so that way you can kind of get an idea. All right, number 3. The top of the piston travel is known as TDC. Okay, the bottom of the travel of the piston is called BDC. So that's where those terms come in. All right. So again, if I were to kind of come in here and draw something for you, here's the top of my piston. At some point in time, this piston is going to go all the way up, and it can't go up any further. It's reached the top of its travel. Okay? At the point where it reaches the top and it starts to come back down, that's TDC. As the piston is moving down, it's going to reach a point in the engine where it can't go further down anymore. It's reached the bottom of its travel. And then it's going to start to come back up. That bottommost point is called BDC. Okay? So TDC is as high as it goes. BDC is as far down as it goes. If I were to come in here and show you here on this last picture, come on. This does not like me this morning. There we go. Okay? TDC is like up here, right? And then BDC is going to be kind of down here. Okay, so pay attention to this. Right? BDC. TDC. BDC. Right? Can I get that concept? All right, let me kind of... There we go. All right, so that's TDC. Now, that is a measurement that we can make. I'm not going to get into why we would make that measurement right now. All right, the piston stroke, vocabulary word. That's going to be the distance that the piston's traveling inside the cylinder, and we measure it at TDC and BDC. That distance between TDC and BDC is called a stroke. Okay? It's called a stroke. So again, if I were to measure, there's TDC, there's BDC, that distance there to there is a stroke. Okay? Now, one thing to keep in mind is, for every 1 stroke of my piston, the crankshaft is turning 180 degrees. So again, if I got a circle here, 180 degrees, okay? So it was right here, it's going all the way over here, and it's going to end here. 180 degrees. Important to understand that relationship, because these two are linked together. 1 stroke, so this goes from BDC to TDC, crankshaft just turned 180 degrees. It goes from TDC to BDC, it goes another 180 degrees. All right, and the terminology we use for that is, again, stroke. Okay, oop. Boy, this is really delayed.
Battery?
No, I got a full battery. I think it's just the way my computer's configured right now. All right, there are 4 strokes in a 4-stroke engine.
Wow. Never would have guessed.
I know, right? Guess how many strokes are in a 2-stroke engine?
Wow.
Okay. We're not talking about a 2-stroke engine today. We're talking about a 4-stroke engine, which is very common in most gasoline engines. Okay? So, our first stroke is called the intake stroke. Intake stroke. It is a downward motion of the piston. So we start at TDC, and the piston is moving down in the cylinder to BDC. Okay? So it's moving downwards. As that piston is moving down, okay, the intake valve right here, this intake valve, is opening up. Okay? Intake valve is opening up. As that intake valve is opening up and the piston is moving down, it's actually creating lower pressure, which means all this air and fuel is now getting basically sucked into the combustion chamber. Okay? So that's what's going on in the intake. Let me go back here just a second. Okay? So, piston's going from TDC to BDC. As it's doing that, intake stroke is opening. Air is moving from the outside in to the combustion chamber. Okay? That's why it's called intake stroke, because we are intaking air-fuel mixture. Once the piston reaches BDC, we move on to our next stroke, which is called the compression stroke. Okay? At this point in time, the piston is at BDC, and now it's moving up to TDC. Both valves are closed. Intake valve and exhaust valve are closed, sealing off the combustion chamber. Nothing should be getting out. Okay? And as this piston is moving upwards, all that air-fuel mixture that was brought into the combustion chamber is now being squeezed into a much smaller space. Okay? That's why it's called the compression stroke. We are compressing it into a smaller area. Okay? Typically speaking, the air-fuel mixture is going to about 1/10 of its original size. All right? Free information, you don't have to write this down, but this is called the compression ratio, which is typically 10-1. Actually, on a lot of modern day vehicles, it's probably more like 8 or 9-1. Okay? Again, you don't have to write that down. That's just free information. Okay? Back up. Okay. I don't have any tissues. You have to walk out and get some paper towels. Sorry. All right. So that's a compression stroke. The third stroke in our 4-stroke engine. There we go. Power stroke. What's happened is the piston is at TDC. All that air-fuel mixture has been compressed. Now what we do is we take the spark plug and we actually ignite that air-fuel mixture. Okay, red's probably not a great color there. We create a little spark in that combustion chamber. The air-fuel mixture, because it's gas and air, ignites. It burns. As that air-fuel mixture is burning, the gases are expanding and it's pushing everywhere inside that combustion chamber. Okay? The problem is everything's sealed up. The only place that can be pushed on is the top of this piston. You know what? Let me try this in a different color. Can I choose a different color? Yeah, well. There we go. Let's go green. Well, yeah, we already did red. Let's go orange. Okay. So, we got a spark. All that gas is now pushing down on that piston. Okay? So we're going from TDC down to BDC. So power stroke is a downward stroke. This is the only stroke in the 4-stroke cycle that's actually powering our wheels. 3/4 of the time, that piston is not receiving any kind of power. All right? Oh, can I exit out of this? Delete. Beautiful. All right. The 4th and final stroke is the exhaust stroke. Again, our piston now is at BDC. We've extracted as much power from that air-fuel mixture burning as possible. Okay? So now what's going to end up happening is the piston's going back up. As it's going up, the exhaust valve is now opening. And now the piston is literally forcing out all those burnt fuels or vapors that were burned, and it's exiting out through the exhaust pipe and out into the environment. Okay? Now, we got 4 strokes. For every 1 stroke, the crankshaft turns 180 degrees. Okay, quick math problem. How many times did the crankshaft turn for every 4 strokes? Twice. So 2 spins of the crankshaft for every 4 strokes of the piston. Okay, there's a ratio there. Okay, the engine can be timed. It needs time. So it's not just when we burn it, or excuse me, it's not how we burn it, but it's also when we burn it. We have to time that spark plug exactly when we need it to. We need to open the valves exactly when we need to in order for everything to work harmoniously together. If something is off time by a little bit, it could cause the engine not to run. Or, worst case scenario, it runs extremely poorly.
You can tell when it's misfiring.
Yes. Okay, so again, real quick review. Let me get my pen out here again. Okay? So, intake stroke, compression stroke, power stroke, exhaust stroke. Okay? And then the whole process repeats itself. So after the exhaust stroke, intake stroke, compression, power, exhaust. Intake, compression, power, exhaust. Suck, squeeze, bang, blow. It's a very easy way to remember this. Okay? We're sucking in air, we're squeezing the air, we're powering it, so there's a bang, and then we're blowing it out. Okay? Intake valve is opening, oops. Intake valve is opening here, exhaust valve is opening here. Nothing's moving in between. Sealed up. Okay? So there you go. If you didn't know how an engine worked, that's how an engine works. Pretty straightforward. Now it's going to be everything else in between. Now that you know kind of what to expect, let's talk about actually everything else. First, let me do a little quiz here. So you got your Plicker cards, right? Remember how to do this? I'm going to ask you a question. That's the question. You can look over your notes, see what you can come up with as an answer. So, the air fuel mixture is actually burned during the power stroke, the intake stroke, the exhaust stroke, compression stroke. Whichever one you think is the correct answer, make sure that letter is up, and then you show me the card and I'll scan it. And by the way, you can change your answer as many times as you would like, but as soon as I shut down my phone, your answer is recorded.
What? Stop cheating.
Look at your notes. It's not cheating. Out of the 4 stroke, which one actually is where the air fuel mixture is burning?
Wait, what's the second stroke after intake?
The second stroke is a compression stroke. All right, did I get everybody?
Yeah.
By the way, I don't know if I mentioned this or not, but this is graded. You're going to get points for this, so if you don't answer, you don't get any points. Just throwing that out there. If you get it wrong, you lose the point. Okay? All right. 5, 4, 3, 2, 1. Yep. All right. Got everybody. All right. 59% of you said power stroke. That is the correct answer. Okay? Intake stroke is where we're intaking the air. Compression strokes where we're compressing it. Power strokes where we ignite the spark plug, and that's when we burn the air fuel mixture. Okay? That powers the piston downwards, and then the exhaust stroke is where we're pushing that exhaust gases out. Okay, so if you answered A, you're correct.
Yay.
All right?
Let's go, bro.
By the way, I'm going to be asking you 4 more questions throughout the presentation, so pay attention, make sure you write down in your notes. All right. The main casting of our engine is going to be the cylinder, or excuse me, the engine block. Sometimes called a cylinder block, but the engine block, okay? That's what you see here. Now, inside that engine block, there's something called the bores. B-O-R-E-S. Okay? Also sometimes called the cylinders. Okay, the reason why they're called the cylinders is because, very importantly, they're round, right? And they're cylinder shaped. I'm assuming you guys took basic geometry in like middle school. You know what a cylinder is. Okay? Depending on the type of engine that we're running with will determine how many cylinders are in that engine. Okay, so if I have an 8-cylinder engine, I'm going to have 8 pistons. Okay, a bore is just geometry terms for how big is that circle, right? The larger the circle, the larger the piston. Potentially, more air can get in, which means more fuel, which means more power. Okay? So just kind of keep that in mind. Now the piston is going to be moving up and down in that cylinder. Okay? So that's part of the operation of that engine. So everything's built around that engine block. The block is going to contain passages for oil known as galleries. Again, this is going to be a good vocabulary term. Oil moves around in something called an oil gallery. You know how your body has like arteries for your blood to circulate around in? Okay, the oil circulates around in the engine through its arteries called oil galleries. Water jackets is the term that we use for coolant. We're not talking about coolant necessarily in the next couple of weeks, but we will be at some point. So we've got oil galleries and water jackets. You should never have oil in your water jackets, and you never should have coolant in your oil galleries. They're separate. Okay? So just something to keep in mind. And this is built into the engine block itself. You can see here some pictures of these galleries for oil as it moves around to get to very critical parts of the engine. All right, crankshafts. They have something called, that are very highly polished, precisely machined bearing surfaces known as journals. Okay, again, another vocabulary term. A journal. Come on, journal. Now you can see here that journal on the crankshaft. We've got a bunch of journals. We got one there, we've got one here, here. Okay, we've even got some other journals right in here. Okay, they're highly polished. You can see that these areas are much shinier than the other parts of the crankshaft. Okay. Now, what are the journals used for? Well, that's where we attach our piston to, and where we actually mount the crankshaft in the engine block. All right. As the crankshaft is spinning, it's rotating around these journals. So that's why they have to be extremely polished and smooth, because they're going to be rotating. If it was rough, it wouldn't work well because you'd have a lot of wear and tear. Oops. Engine rod bearings are low friction precision inserts that support the crankshaft, okay, at the journals. And again, you can see here on this diagram, here's my rod bearings. They are put together around this journal, and that's basically what supports that crankshaft. And again, we have multiple bearings that go on that crankshaft to kind of hold it in place in the engine block. Now, here's something interesting. Again, you don't have to write this down right now, but the rod bearings will never actually physically touch the crankshaft, even though they hold the crankshaft in place. Isn't that weird?
Wait, how?
The rod bearings will never physically touch the crankshaft.
Nice.
But the rod bearings are designed and their purpose is to hold the crankshaft in place. So how is it that the rod bearings can hold it in place without actually physically touching it? Very simple. Oil. There's a very thin layer of oil between the rod bearings and that cylinder or crankshaft journal, and that's what's causing it or allowing it to spin while staying in place. Okay? You don't have to know that right now. I just wanted to share that with you so that way when we get to it, it makes more sense. That's why those crankshaft journals have to be so polished. Okay? Because the distance between that rod bearing and the crankshaft is like the same distance as a human hair. It's very small. Now, to help the crankshaft spin and to counteract the piston moving back and forth, the crankshaft has built-in counterweights. Okay, so right here you can see I've got counterweights on that. Here's an actual crankshaft. You can see I got counterweights there. I've got a counterweight here. Counterweight here. It's there to help balance the engine. So as that piston's flying out, we have an equal weight going in the opposite direction. Okay? And if we have an equal weight going in the opposite direction, it balances it out. It eliminates engine vibrations. And it allows spinning momentum. So that way it's easier to turn that crankshaft. The easier it's turned that crankshaft, the more power we can extract, which means more efficient that engine becomes. The more horsepower we could potentially extract from that. Okay? So it's all part of the plan here. Man, time flies when you're having fun. All right, the crankshaft snout, right? That's its nose. The snout, the sniffer. The snout sticks through the front of the block. Let me get my pen out here again. Okay, the snout sticks through the front of the block. Okay, while the crankshaft flange is in the back of the block. Okay, so here's my crankshaft, right? I'm going to have, well, I think these are both going to end up being the flange. The flange is going to have the flywheel or the flex plate. Not super needed to know right now. And then the snout, we're going to talk about later, that's going to have our vibration damper. Okay. So the snout sticks to the front, flange goes through the back. So if we put it all together, here's our crankshaft. We've got journals, highly polished areas that are going to hold the piston and the crankshaft in the engine block. We've got the snout, front, and the flange in the back. Okay, we also have counterweights. So kind of we're breaking down what a crankshaft looks like and the parts on the crankshaft.
What's the name for the automatic transmission? I know flywheel's manual.
Flywheel's manual, flex plates automatic.
Okay.
Yep. Okay, we're not going to get into that information for a while. Right now we're just focusing in on this. All right, can I move on? There we go, right? Yes, okay. So we had our rod bearings that hold the crankshaft in place, but we also have a very special type of rod bearing called a thrust bearing. Okay? This special rod bearing prevents the crankshaft from shifting forward and backward as it's spinning. Okay? That's what a thrust bearing does. Okay, typically speaking, this thrust bearing is going to have kind of like a shoulder on it, which you can kind of see right there, which distinguishes itself from a normal rod bearing, because a normal rod bearing would not have this shoulder. Okay, and again, that shoulder is designed to prevent the crankshaft from shifting front or back as the engine's running. We want the crankshaft to stay in place. We only want it to spin. We don't want it to be moving around all over the place. Okay? Trying to find it. We can actually go out and we can measure our crankshaft end play, it's called, and know if it's too much or too little. All right. We're going to do one more slide here. The crankshaft is going to be fit with both a front and a rear main oil seal. This is going to obviously prevent oil from leaking out of the engine in the front or the back. Okay? But this seal, right, if my hand here is the crankshaft, it's coming out of the engine, I need to kind of have something that goes around it to prevent leaks but still allows it to spin. Okay? That's what this does. Okay, this is kind of what it looks like. It's kind of got this rubber coating around it to allow for that twisting motion of the crankshaft. Here's one that's kind of got a boat ready to be installed. Okay, we got a rubber black seal around that. All right. Oftentimes, if people have an oil leak in their engine, it could be that this seal is worn out and it needs to be replaced. Okay? Which, by the way, not fun to do because you are literally taking off your transmission if it's a rear engine, rear oil main seal, or you're taking off pretty much everything in the front to get to the front main oil seal.
You have to deassemble the entire block.
Not the entire block, but you're gonna have to take a lot of stuff off of the engine.
Like a good 60% of the block.
Yeah, just to be able to get that. So typically speaking, you don't want to be doing that a whole lot.
I assume it would be easy, it's just annoying.
It can be annoying. It can be very annoying. All right.
It's just a process.
We're on number 16. I will write that down. So tomorrow we'll pop back in and keep working on this. I know that was a lot of information, by the way. Okay? Tomorrow we're going to go through and we're going to let you guys review some of that and get it back in your head and kind of start making connections.
I don't know how I got
I'm going to stop recording.
Like,